All right. Hello, everybody. We're back again looking at some of this quick work with discrete probability distributions for our statistics course, right? And so a discrete variable or discrete probability distribution, right, is this distribution that's set up, right, with distributions we talked about with frequency distributions before, was that work with organizing our data, right, into a table. In this case, with our probability distribution, we have in one column our variable value, right? What results we can get. And in the other column, our probability, kind of like our relative frequency. So I'm going to share some notes here, some practice that we're going to see in our calculation. All right. And let's see how this goes, right? So looking at this example, right, we have a probability distribution or a discrete variable probability distribution, right? Our variable x represented by these distinct discrete values, right? 1, 2, 3, 4, 5. They can be, a lot of different possible values. Most often they're going to be whole numbers, but depending on what we're describing, what our variable represents for us, it can take on a broad set of values, right? It doesn't have to start at 1, doesn't have to start at 0. It can start anywhere. It is wrong as long as it represents a particular quantity for us. And then alongside their associated probability, the likelihood of getting a 1, the likelihood of getting a 2, so on. In this case, in our problem, this probability distribution represents the number of math majors, right? So in this case, this X represents our number of math majors, right? These students that are majoring in math in this class, okay? Math 20 and Calculus 20C, Math 20C here at MPC, right? Our third semester multivariable calculus, right? So looking at these, and we'll kind of look at it using that table, we can start to calculate, and really the calculation is just kind of pulling from these values. Unlike our probabilities in the previous discussion, in the previous chapter of our course, where we have to like kind of figure out how many students total we have, how many meet a particular criteria. Now that work's been done for us, thankfully, and organized. So now in this problem, what's the probability that in Calculus 20C, right, this course, this section, there'll be exactly 2 math majors, right? So we're looking for this probability that X is exactly equal to 2. And so just taking from our table, right, the probability of 2, taking from our table up top here, the probability that we get 2 students that are math majors, that's 0.143. So no calculation necessary, no rounding necessary in this problem. It's just taking that value directly from the table. So now as we start to go forward, thinking about a little bit more of those criteria, some of the different ways of organizing and thinking about the inequalities, if you will, what's the probability that in this Calculus 20C section, there'll be more than, sorry about that, 3 math majors, okay? Looking at that phrasing, more than 3, right? So in this case, we're looking for the probability that our X value, right, that number of math majors, is going to be more than, so in this case, it's going to be strictly greater than, bigger than, right? I don't want to even have 3, I want it more than 3 of those math majors, okay? And so in this case, thinking back, this, okay, will be more than 3 in this particular arrangement, in this distribution, those values for X that occur, we're looking at having that be either 4 or 5. And now we want to keep track of some of that wording, right? At least or more, right? Whether we need to include that 3 or not, whether that's a greater than or equal to, or in this case, a strict inequality, strictly greater than, that phrasing, that wording is going to become important, okay? So in this case, well, definitely more than 3, I'm only looking at 4 or 5. And again, pulling from our values above, the probability of having 4, 0.383, right? So there's our probability for 4. Or we're going to add, right, that probability of having 5, and from our table there, 0.059. And doing that addition, making sure I don't make an error with my decimal work. Doing that addition, our result turns into 0.442. Right, so just be careful as we're looking at these problems in our distribution, right? What values we want to work with, how that arrangement is being set up, okay? And so then building on, kind of tying our work into some of the discussion we would have from chapter 3 with a bigger set of data. Now we're going to look at our expected value and that standard deviation, right? Kind of see how these results, if I was to go through this experiment, look at multiple Calculus 20C sections over the span of years, different instructors, whatever it might be, right? Different colleges even, what our expected value is and the standard deviation, right? The deviation in the amounts we would get. And so looking at this information, our expected value, this is kind of like our mean, okay? The average value, if we were to do this operation, this observation or more, what we expect to see, right? The average of those results. And of course, that standard deviation, how much we deviate, how that variation, okay? That consistency of getting that expected value, right? And so in this case, for our expected value, the mean, of course, we can call it mu, but here we call it E of x, right? Our expected value for those x quantities. Our standard deviation, I'll still give it that sigma, that standard deviation symbol. And so now I'm going to switch over to how we would do this with StatCrunch, right? So now this is going to be the important aspect. And so if I switch over real quick to looking at StatCrunch, all right. So now we should see our StatCrunch, over so I can see it, our StatCrunch calculation table. And so in our StatCrunch, depending which column you want to work with, we're going to do one column for the x values, one column for the probability. You can relabel if you want to, right? Your x, your p of x, right? Or you can still leave it as var1, var2, so on. But for x values, 1, 2, 3, 4, and 5, taken from the table, our frequency distribution, our probability distribution, pardon me, 0.028, there's its probability, 0.143, 0.387, 0.383, and 0.059, right? And so these, again, the probability, the likelihood that when I make this observation, how likely I'm going to have exactly four math majors, 0.383, 38%, right? How many times I'm going to have 3 math majors, 0.387, right? 38.7%, almost 39% of the time, so on. And so now if I want to calculate the expected value of the mean, our standard deviation, what we're going to do, we're going to go to stat calculators, but now we have to go to our custom calculator, okay? This is similar to calculating the mean standard deviation for group data, but now instead of having those frequencies, now we have the probabilities. So we're going to do a custom calculation, and we're looking at a weighted mean, okay? So the weights, these are going to be our probabilities. So our variables are x's, that's the values that we get for our variable, right? The weights, that's our probability, that's our p of x. And now we compute. And for those values, we have our mean, that's our expected value, and the standard deviation like so. So I'm going to go back to that paper, okay? Now we're going to see where I type in these values, all right? I'm going to stop the share here. I'll go back to our sheet. And so from that StatCrunch, I'm going to sneak over my shoulder to look over there. The mean, the expected value from StatCrunch, right? 3.302. The standard deviation, 0.88475,759, right? And so in this case, just to remind, this is on StatCrunch. Underneath that stat menu, custom, okay? And this is, it doesn't have that title there, but what we're calculating a weighted mean, okay? But this is our operations. You go to StatCrunch, you go to the stat menu, you scroll down to custom, okay, or calculator, sorry, stat, then calculators, there we go. Okay. And then down to StatCrunch, or the custom, pardon me, there we go. And we'll see those results. The mean, standard deviation. And in this case, if I want to round my results to one decimal place, that means that our expected value, I'm going to sneak over here, 3.3, our standard deviation, 0.9. Okay, if I round those results to just one decimal place, and again, depending, I might have you keep 2, but all just depends, okay? But in this case, we have our values. And so then now, similar to what we did, kind of tie this back into that chapter 3 work, okay? We can make this number line using our expected value, that mean, and our standard deviations for that distribution of these possible results, okay? And so then, if I make my number line, give myself a different work, right here, X, the number of math majors I might identify. In the middle, okay, I'm going to put that expected value, the mean, in our rounded value from above, right, that 3.3. I'll use that value. Then we start to work our way out by taking one standard deviation above, one standard deviation below, 2 standard deviations above, 2 standard deviations below, so on, right? So if I do this first set, right, we're going to take that expected value and we're going to subtract 1 standard deviation, right? Likewise, we're going to take the expected value, that mean, and add 1, the blue here, 1 standard deviation. So now we're 1 standard deviation above, 1 standard deviation below. So that's, right, 3.3 plus 0.9. And depending on how many decimals we keep, right, probably more formally, I would calculate with the entire decimal and round at the end. But with our work that we see from above, doing those additions, subtractions, right, real quickly with my scientific calculator, 3.3 plus 0.9, 4.2. Okay. 3.3 minus 0.9, 2.4. Right, so there's 1 standard deviation above, 1 standard deviation below. So we think about the empirical rule, right? If we were to do this experiment hundreds of times, observe hundreds, thousands of these Math 20C third semester calculus class, we kind of expect that 68% of the class would have between 2.4 to 4.2 math majors. Okay, then we can go another step out, right? We can take our expected value and subtract minus 2 of those standard deviations. Take that expected value and add 2 of those standard deviations. Right, kind of broadening it out, getting more of our data there. So similar, 3.3 plus 2 times 0.9, or you can multiply that 0.9 times 2 earlier, and then add, right? But either way, it's going to be this 2 times 0.9, or that 1.8. Doing that addition, 5.1, right? So up here, I'm going to put in purple, 5.1. Doing the same thing with the subtraction, 3.3 minus 2 times 0.9, and I'm getting down here 1.5, right? And again, you can let that work. 3.3 minus, and then again, we're trying to make sure we multiply that 2 first times the 0.9, then subtract, okay? 1.8, 3.3 minus 1.8, right? 1.5. So just to verify that calculation. Okay? Just to show. And so that's where we're getting, right? 2 standard deviations above and below. So there's that number line, our expected value, that 3.3 in the middle, right? 68% should be between those values, 95% between those quantities. And so when we start to expand, let me kind of stretch out my number line here a little bit. Similar to what we would have discussed with our standard deviations, now with our probabilities, so on. Now, anything below 2 standard deviations, above 2 standard deviations, this would be considered unusual. Right? Just like our z-scores. Anything with a z-score bigger than 2, smaller than -2, beyond 2 standard deviations from the mean will be considered unusual. So just like with our outcomes here, it's unusual to get a result more than 2 standard deviations from that expected value. And that's how we do that classification, similar to what we did in chapter 3, talking about the mean standard deviations, now applying that with our discrete probability distribution. Okay. All right. So fairly quick work in this chapter, this discussion with probability distributions. Here, the interesting part, or the more complicated part, if you want to call it that, using StatCrunch to calculate that expected value, the mean, and our standard deviation using that stat calculators and the custom calculator is kind of way to mean. All right, y'all.